Hi everybody, I'm 97% of Odin the Nerd. The other 3% was hair and beard, and that's gone now. So I look like I might get mistaken for a businessy kind of person. So I'm going to run with it because I've actually never told anybody what I do in my day job at the beginning of the talk. But apparently businessy people who have haircuts do such things. So I founded Auto Intern, top left there, in my living room 20 years ago. And back then I basically soldered things and stuff blew up and whatnot. But I actually made money off of it. So after the diagnostic tools that we build in Auto Intern, we started a diagnostic tool specialty resale company, which was only fun from a database perspective and search engine optimization and blah, blah. The fun part, the part that I do most in my day job, is Skynet and NerdForce One. Skynet is a contract development company. We will build the Terminator for you if you want. NerdForce One is a consulting company, and we also do events. We do Envo Conference, which is for how to build Terminators, as in bare metal, hard real-time, microcontroller-y stuff. And the last one down at the bottom there, Nerd Couture, is a t-shirt company and a lifestyle product company, because basically I follow the philosophy, if I want to buy something and I can't, then I make it like viable. Although we haven't quite made it viable yet, because apparently it's hard to get like very good quality t-shirts made in small numbers. But sort of as a nerd, like I express myself through t-shirts, and the problem is like I'm expressing something awesome on my t-shirt, but I'm also expressing that it's like a cheap t-shirt and it's never seen a graphic designer and so on and so forth. And that's mostly what I'm expressing to like my wife and other normal people. So I decided to try and fix that problem. Previous talks under the same title of, coming to the actual talk part of the talk. Previous, boost.tmp talks have been about benchmarking template metaprogramming, and I threw this slide in here. This is a Cartesian product. We have amount of time it took going up and amount of elements coming towards me. And we have in green Eric Niebler. We have in some kind of beige tone, we have Peter Dimhoff. And then we have Bruno Dutra in red, and Giel Douwes in black at the very bottom. My co-author of the Quasar library. So I don't have any skin in the game here, but ranges v3 might get quite a bit faster, right? Is kind of the takeaway from this slide, because least contingent product you can do about 100 times faster, right? But that's not what this talk is really about, right? This talk is, I'm sorry for sort of past talks where I just showed a bunch of, code and whatever. And this past, this is not necessarily my rampant spelling errors in all of my previous talks. This is obviously the post-angle bracket stress disorder that I've caused in my previous talks on this topic, right? So in this talk, we're not going to see angle brackets and template disambiguators and whatnot. We're going to actually see the clean, the expressive, the domain-specific language that we're going to put on top of all of this so that users don't get passed. So we have several domain-specific languages in C++, and we're actually getting a new one. We have, inherited printf from C, and it's contentious. And we fixed it with IOStreams, or not. Also contentious, right? Also a DSL. Then we have regex, which is a more powerful DSL, but it's a runtime evaluated DSL. So we didn't get that one right either. Hanna Dusikova is fixing that, but yeah, so we don't really have a very good track record when it comes to DSLs within C++, and we're getting a new one, right? So most of the audience has probably heard of ranges, but here's a little sort of refresher, right? The idea with ranges is, rather than begin and end iterators, we say, okay, some set of something, some range of something
is expressed as a single data element, right? And it can get piped from one operation to the next, and that's the DSL part, right? So we have a vector of things, we pipe that vector of things into reverse, and then we pipe that reversed vector of things into transform and make them all awesome, and then we pipe that into a filter, because some of them, some things just can't be made awesome, right? And then at the end, we do something with it. Right? And the advantage of it being a DSL, rather than doing this as composed functions, is that you can be lazy, right? So me as the implementer can see this whole composition and maybe make them awesome first and then filter and then reverse, because then it's less elements, or I don't actually have to create intermediate containers in between those. I can just lazily say, hey, this thing, it's not over there anymore, it's over there, and it's awesomeified, and it's filtered, and give you an iterator that just skips over the ones that can't be made awesome, and so on and so forth, right? So this is the new DSL that we're very, very probably getting into C++. The question is this a good thing? We don't have a very good track record on DSLs in C++, right? So this is kind of the getting everybody in the right mindset for the rest of the talk part, right? We're going to do sort of a philosophical deep dive, like what is good? With a quote that some people here might recognize. Conventional programming languages are growing even more enormous, but not stronger. Inherent defects at their most basic level cause them to be both fat and weak. Their primitive word-at-a-time style of programming inherited from their common ancestor, the von Neumann computer, and a few other flamity-flame things, and then their lack of useful mathematical properties for reasoning about programs, right? This was obviously Reddit user Flamey McFlameface. No, it's actually John Bacchus from before I was born at his Turing Award speech. And he was getting the Turing Award for Fortran. He was, the inventor of Fortran, right? And the ironic thing is, or the thing that actually makes this stand out, is Fortran is a word-of-the-time von Neumann style language, right? So he's railing against his own baby that he got a Turing Award for at his Turing Award ceremony. So why is he doing this, right? And I've noticed this same behavior in some of my friends who start programming in functional programming languages and then they never come back. And so the conclusion obviously is that the functional programming community has some very hard drugs, right? No, I mean there's power in having a very small set of things that can be composed to create bigger things, that can be composed to create bigger things, right? I mean, this is what sort of Stepanov was reaching towards in his generic programming infrastructure and standard library. And if you look at the Stepanov portion of the standard library, we have a very good track record there, right? I mean, there's a difference in creating libraries where either you're implementing things into the library or you're trying to come up with the smallest set of things with which you can express all the things, and then discovering all these other things that you can also express with those semantics, right? It's more of a, I'm going to discover what I can do with this set of things rather than I'm going to go implement this stuff, right? So, applying this to the ranges, DSL, I think this is a good thing, right? This is sort of a set of generic concepts with which we can build an unlimited amount of things, right? So if it's good, let's take it to its logical end. That's what most of the rest of this talk is about. Let's discover other things that we can do with this DSL, right? And this is in the name of my boost.tmp library because I discovered this on my way to trying to make a metaprogramming library. It's not actually in Boost yet, so disclaimer, like Boost and square brackety things. I haven't haven't even submitted it yet because I keep discovering things that it can do, right? So TMP doesn't actually stand for template metaprogramming. It stands for tacit metaprogramming. Tacit is actually the style of programming that we're using with ranges v3. I mean, you know tacit not by its name, but from shell, right? You have pipes in shell as well. That's where the idea probably came from for the ranges pipes. So here we're piping ls into head -3, as in we're taking the first 3 things in the directory listing off, right? We can pipe that into tail -1. Let's get rid of the last one. We can even pipe ls into grep to have DSLception, right? We have regex DSL on top of the tacit DSL. And this gives us a different way of composing functions, right? I mean, in ranges, we're composing, range algorithms. And classically, we compose functions like this, right? We have some input, goes into H, return of H goes into G, return of G goes into F, and return of that, right? In sort of a tacit pipey fashion, we'd express this way. Input gets piped into H, return of H gets piped into G, and so on. So it's kind of the other way around, if you will. Both of them are pretty good at expressing this, right? I have 2 parameters going into H. H returns 1 parameter, goes into G. G returns 1 parameter, goes into F, and so on and so forth. But what if we have H returning 3 parameters, right? We don't really have a way to express that in C++. I mean, we do have apply, right, which takes a tuple and a function and takes the contents of the tuple and calls a function with that, but that's kind of ugly and hard to explain, and I can never remember which way around they go. In the tacit form, though, I mean, this is our own playground, right? We can make this work if we want, right? I mean, tacit is a metaphor, a synonym for quiet, right? The idea why it's called tacit is you don't actually say what the names of the parameters are. You just say declaratively where they flow, right? This return flows into that return flows into that. And this is powerful for several reasons. It actually saves you a lot of moving and forwarding too, right? Because if something's an R value and it never actually got a name, it stays an R value, right? So there's a lot of things one can discover about sort of this alternate style of expressing oneself. So let's apply this to the fusion style metaprogramming that I originally set out to solve. This is kind of what's in Boost now. This is Boost HANA. If you're not familiar with HANA, the idea is you have a tuple of different types, right? Fish, cat, and dog are different types, but they all have a name. So we can make a generic function, right? Notice in the lambda we're taking by auto, so it's a templated function call operator. So A can be any one of these types, and we're calling .name on it. And then we can transform over our container of animals, right? Applying this getName function, and the return of this, the type of names, is going to be a tuple of string, 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 right? Or whatever the .names type is. HANA will figure it out and do it for you. So this is quite powerful, but in my opinion, it's a little bit the wrong sort of public interface. Because if we start to compose these things, we get into somewhat the same problem, right? I mean, in HANA, tuples are essentially the lingua franca, right? So if you return a tuple and then you call another algorithm with that, well, it's going to unpack that tuple and use it, right? But that means that we have some performance disadvantage, right? So this is the equivalent tacit version, right? We take animals, pipe them into transform, pipe that result into reverse. Same thing, just backwards because of tacit programming with pipes. Right? So if we look at that pipe, what's going through that pipe? It's unobservable, right? Because we can take this whole expression of all the things, look at the whole composition, and then evaluate it, right? So with HANA, transform was returning a HANA tuple with a big public interface and all this other stuff, right? But what's going through that second pipe, I can make that be different things on different compilers, whatever's fastest. It doesn't have to have a public interface. I can make this much, much faster because less stuff is observable, right? And so functional programming is actually mostly about making stuff, disallowing things, right? We're not enabling things, we're disallowing things so that we have less stuff to reason about. And because we have less stuff to reason about, we can reason further, right? So this can, reduce compile time considerably in sort of my first, by no means highly optimized tests. I'm getting, 3 to 10x faster compile times than HANA. Yeah, question?
So the key point, as I'm understanding, is that overloading this pipe operator allows you to have like your own private interface depending on which compiler.
Yes.
Couldn't the same be done with HANA as well? Just that HANA is kind of set in stone already. It could have the same interface but with the new library.
The problem is that transform doesn't know that its result is going into reverse because it's not expression templates, right? I mean, I'm going to have to kind of defer that answer to a whole nother talk called Expression Templates at Scale, which hopefully I'll hold at C++ now. But you don't have, in sort of a non-tacit interface, you can't look down the chain of things to do and do things differently depending on what the next or the thing to do is or the one after that, right? So in order to be able to do this, we have to extend the concept that we have in ranges, where ranges can go through pipes. We need to have other things be able to go through pipes, right? We need packs to be able to go through pipes, right? And so what a pack is not necessarily observable. It's a concept, right? Like it's not something where you can say, oh, does it have this member function or not? No, you never actually see these things. These are within the implementation, right? So this is, somewhat language level tuple-ish, right? There's a lot of people in the standards community wanting a language level tuple, and I said, well, okay, maybe we should see how far library space can go first and then decide, right? Product type meaning the sum of its states is the product of the states of all of its members, right? So this is the syntax that I want, right? I have a pack, and I pipe this pack into transform. I can't have that syntax because you have to unpack a pack, right? The A is a pack, so the preceding ... But I can work around that. Say, okay, I have a factory function called pack, and it'll give me a pack. And pack is implementation defined, but it fulfills this concept of basically pack that you can push through pipes, right? And then this will actually almost work, except there's another vexing thing in C++. What are foo and bar, right? I mean, if these are function objects, then this will work, right? But if these are free functions, this will work as long as they're not overload sets of free functions, right? As long as there's just one, it's not ambiguous which one you mean. But if transform is taking a function reference, then it's got to be generic because transform doesn't know what types are coming in, so it doesn't know what types it's going to be passing to foo. So if there are multiple foos, which there very probably are going to be because, again, it's a generic context. Foo is probably going to be a template or an overload set. And the language doesn't have the semantics to say, I want that whole overload set, right? And I can, get around it with a macro, which basically just puts this in a lambda and makes a function object out of it. There's also a paper, P1170, I think it's the third attempt to bring this into the language. Again, somewhat beyond the scope of this talk, but the idea is, we can make workarounds to make the syntax close to what I want, and it will go towards what I want long term. The other problem we have here is what are we returning, right? It's a problem with expression templates. When do you stop being lazy, right? When do you actually calculate the result? And it used to be when we had strong types, well, you'd be convertible to that type, and then you do all the work when you're converted, right? And then auto kind of screwed that up. So short term, we can get around this by saying, hey, this comes at the end, decay or done or go gadget or whatever you want to put there at the end. We can make a more strongly binding, as a later binding operator. I mean, if I'm losing some people, don't worry, I'll pick you up again in a minute. This is all expression template-y stuff, right? Point is, it's fixable. And we might get something called operator auto. That's another paper. We'll fix into expression templates, right? So let's actually go back to sort of the user interfacey part, right? So if I have a tuple, can I pass that through a pipe? Like, what does that mean? I take foo as a function, I pipe, well, does that apply? Well, maybe, or maybe I just want to put that past that tuple, right? I mean, this is not necessarily the use case. The use case is where foo returns a tuple and is the second one in the chain. That second pipe. Is that second pipe a tuple of int and bool being passed to bar? Or is that second pipe an int and a bool being passed to bar, right? It's ambiguous. Sometimes you mean one, sometimes you mean the other. So we're going to introduce a new concept to the ranges v3 DSL. This concept is called unwrapping, right? So if I want to pass the tuple into bar, I just pipe it. And if I want to pass the int and the bool into bar, then I unwrap it and take the pack containing a tuple and turn it into a pack of an int and a bar, because packs go through the pipes, right? And then I can express both, right? Yes?
Isn't passing the tuple the rare case?
Yes, it is the rarer case. However, it's much harder to explain the other way around, like rewrap or retuplify or rething it used to be a phi. A very good point, but yes, I try to, whenever I get stuck, I try and write documentation. And if I can't write the documentation, then I have to do it the other way around, right? And this was one of those cases. There's actually an unwrap operator proposed within the coroutines, the core coroutines proposal. I'm not sure if that's going to get in. But if we're sort of unwrapping and piping, like it's not like anyone's ever used that operator for that before, right? It is, somewhat the unwrap and bind, right? But we can't really use that operator. And we're coming to the joke part of the talk because of some profound knowledge, right? This is deep, right? There are compositions of things, and with structured bindings in C++17, we can suddenly unwrap a whole lot more stuff, right? Anything that has structured bindings, we could potentially unwrap that, right? Here's structured bindings in practice, right? And if you don't get the joke, this is why is there bratwurst going into the unicorn factory? Well, this is from a previous talk. If you wonder where all the unicorns are, the evil Germans made them all into bratwurst, right? This is actually a product you can get in German supermarkets, because obviously if your kids love unicorns, then you go buy a ground up one and feed it to them. I don't really get this product, but so if you want like a unicorn, then you have to take a bratwurst and remove all the entropy, and then you have a unicorn again, right? So that's the get bratwurst part, right? This is the interesting part, right? We can essentially unpack more things. And this is where this operator runs into problems, because a lot of things are unwrappable with structured bindings, and some of them might have a right shift equals, right? So this could be ambiguous. Something that I'm pretty sure will never be ambiguous is pipe tilde. Anyone know that operator? It's actually not one operator. The tilde is a bitwise knot. Huh? Yes, like the goes to operator, right? It's actually two operators, right? So we have some tilde operator that works on anything that's either part of our DSL or has a callable interface and is a free function. If your code base has that conflicting with something, then you're a terrible person. So yeah, we could build this currently. We might get unwrapped. Well, while we're at it, I mean, give me my own operator, damn it. I can't make that work. So what about optional, right? So we can unwrap tuples. What does it mean to unwrap an optional? Right? So if there's something in there, then I'll do something with it. And if there's nothing in there, then the result is still nothing. So I can just skip doing something with it. Right? So I take a horse and I add magic. And since this is supposed to be composable and everything, we can just add a horn and then unicorn, right? But maybe you can't add magic to every horse. Maybe there are some horses that just aren't amazing, right? Well, we could make add magic also return an optional and unpack that again, right? So maybe you gave me a horse. If you did, I'll add magic. If you didn't, it's just nothing, right? And maybe I could add magic. Otherwise, it's just nothing, because what's the point, right? And if I still have something at the end, then I can add a horn to it, right? So this is nothing new, right? Oh, sorry, getting ahead of my slides. If I'm, a generic lambda, then maybe I also want to take a R-value reference of a horse, right? Which is where this code gets fun, right? The terse lambda syntax isn't so terse if you want to use perfect forwarding. So I'm presenting the even terser lambda syntax, right? Because, what I want is a callable that will give me something. I unpack it, perfect forwarding everything, and I can just do that, right? I mean, the result of piping this thing into my keyword lambda, as in some global constexpr placeholder, is a callable object. And if I give it something, it'll just do this to it, right? It's a powerful DSL. So I'm not the first person to sort of suggest this kind of operation with optional. Simon Brand has Simon's cat, as in can or can't it fit on a slide? No, anyway. This is sort of programming out several steps of doing things with some optional in Simon's proposal. And his proposal is to add a and then and a map function to optional so that we can make it monadic, duck for tomatoes. Yes. Since we have the concept of piping and unwrapping and our terser lambda syntax, we could essentially express the same thing, somewhat terser. And if you're familiar with the concept of the ranges DSL plus unwrapping, it's somewhat logical, right? Like, we crop cat might give us something back or not. Add by time might get something back or not. And as soon as we get a nothing, then it just short circuits and we don't do the rest of the chain, right? Yes?
Just to be clear, in that case, crop to cat and bow tie are they special expression template magic, or are they just normal functions and lambdas do?
They're normal functions, returning optionals, right? So the ones that return optionals get the optional unpacked. The ones that don't just keep on piping, right? So these are just normal functions that you'd write yourself. You don't have to write any of the magic, right? It's all in the operators, right? So there's actually a boost parameter library. Who's familiar with boost parameter? No one? That's actually good because boost parameter is terrible. Boost parameter is a named parameter library developed for the boost graph library because they have the problem of many defaults, right? If you have many defaults, that's not something that you can ergonomically express in C++ well, right? So we can basically replace this entire library with one more concept. And this concept is a T, right? So what's going on here, we have, get image, get width, get height. These are basically filteral algorithms that are looking for something with the name parameter, that fits the name parameter predicates, right? And T basically just takes all its input arguments and pipes them into multiple things, right? It's a T fitting in a pipe, right? So water goes here, T down here and over there, down here and over there, right? It doesn't quite obey the laws of physics because all of the water gets to all, right? All of the arguments get to all of the functions in its list. And then the result that gets piped into the next thing, this pipe here, this is the result of get image, get width, get height, right? So they were called with all the parameters the user passed in, and each of them goes and picks out their parameter, doesn't matter which order. And if they can't find it, then they'll build a default or throw an error or whatever we implemented in here. And we can make a one-line replacement for boost parameter. So we're noticing this is somewhat powerful, right? But let's go to hyperdrive, right? Right? What does it mean to unwrap a variant? Right? So I have a variant, which is sort of a container around a sum type. Sum type meaning its state is the sum of all the possible states of the thing in it, because it's either the one, or the other one, or the other one, or the other one, right? So if we add sort of the concept of sum types going through pipes, a union's kind of a sum type, but it also doesn't know its type, right? We don't really have a good way of expressing a sum type in C++. So we just have this concept of a sum type, right? This is so coming out the end of this, pipe tilde is one of something, right? And so depending on what it is, we're going to call a different foo, right? So this is essentially visit, but it's a more powerful visit because we have all the other stuff in the DSL still, right? So by adding sort of sum types to our things that can go through pipes, right? Either ranges or product types or sum types, still not a whole lot of concepts, right? We could, what does partition mean here, right? This is the compile time partition. So this is a compile time predicate. So I'm saying if you are one of this category of types, you're on this side of the partition. If you're one of that category, you're on the other side of the partition, right? So if you're a pod, we'll say, then you're going into overload set foo. And if you're not a pod, you're going into overload set bar, right? Who's had the problem of having two overload sets as visitors and wanting to put both of those categories of things into one variant, and you have to write your own new visitor? Why, right? Why can't I just compose them? Right? I have this problem in my day job a bunch of times because I have my events going through queues and event pumps and whatnot are variants. And I don't want to write a visitor for every event in my program. That's stupid, right? That breaks encapsulation. I don't want to do all this event routing. So why don't I, getting ahead of myself. Why don't I, write a filter saying, hey, I'm this object, I consume this kind of events. Hey, I'm that object, I consume that kind of events. And then you compose them all and then just have the library route them where you want them to go, right? We have filters, we have partitions, we have all that kind of stuff, and we're a very composable world, right? So we're discovering things about what we can do. So all of you people who are just on the fence about whether to switch to Rust because Rust has Rust match, what is Rust match, right? Rust match is a filter on a sum type, right? So, I was thinking about putting in the slide, you can actually make the Rust match operator with the equals and then the thingy if you make it a macro and then taking the address of the equal. Anyway, I'm going to spare you that because it would give post angle bracket stress disorder, right? So this is pretty clear, right? If something's an int, then call foo with it, right? If the variant holds an int, call this. Okay, bind is adding a new concept here. If it's a char, then add this parameter to the front, then the char, and then that parameter to the back, and then call bar with that, right? So this is, advanced REST matchiness, right? If you think about, okay, what's a bind? Bind is basically a T with special syntax for the underscore position thingy, right? So this is just a little syntactic sugar over top of T. This is not a new concept. Then we have, angle brackets, right? This is from the type-based metaprogramming library, which is also tacit. It just doesn't have pipes. It's piping things into the last parameter of everything, right? So if we look at is integral is going to, say is it integral, and then pipe that into not, right? And so if it's a pod and it's not an integral, then we're going to match and pass this into this generic lambda, right? So it's a little more powerful than Rust match because we can, right? Or you can just be tame and, use the normal library, filter for one that matches this thing, right? So I can express my queue dispatch pretty well, right? I give each one of my components a compile time expression, filter predicate expression, and then I just dispatch to all of them, right? So this is sort of awesome, and we'll get back to how awesome that actually is in a minute. But before that, we're going to look sort of at the very, very forward-looking, future-y end of things. I've never had any use for async. I've had a bunch of almost use cases for async and future, but they're all almost use cases, right? And the future.then and the proposed unwrap that was proposed a while ago and got shot down because some people hate monads, would have been another DSL in C++, right? The .then is arguably almost a DSL. It's just terrible enough that it's not a DSL because nobody uses it, right? The problem is you can't really compose things with .then without making all of your functions take futures, which kind of defeats the purpose, right? But sort of in general, if we were to say some asynchronous channel can also go through pipes, I'm not sure if this will actually end up working for everybody's domain. It does kind of in mine. If I were to say, okay, it takes a while to take out all the entropy, right? So why don't we do this asynchronously? So what does it mean to unwrap a future? Well, I want the thing that's in the future, so I can either wait for it, but I'm lazy, and I'm a lazy DSL, so I can do .then, essentially, right? So I could chain these things, right? So if I want to get rich, I need a unicorn, so I can make a rainbow, and then I need Lucky Charm, so I can get a leprechaun, and then I need a shovel, and so I can get my pot of gold, and all that stuff, right? But I probably don't want to do these in a chain, right? And probably all of these are going to be futures, so I probably ought to unwrap them again, right? But I probably want these to be not a chain. And this is terrible because it doesn't fit on a slide, but actually in a code editor it looks a little better. What we're doing here is we're taking some input parameters. We're using async t to distribute these to different asynchronous tasks, and then we're gathering them all together with the and here, right? So this is essentially a flow graph of asynchronous data, and this is where I kind of wonder how other people think about asynchronous tasks, because asynchronous tasks are bound together by some communication channels, and that the result of that is some large graph of where data can flow. And it might not be a pretty graph, it might have cycles, it might have all sorts of crap in it, but it's still a graph, right? And if we try and express a data flow graph in procedural programming, we're going to shoot ourselves in the foot, because if you think about it in the data flow graph, it's obvious that you should get to the same result no matter which part takes how long, right? I mean, if this one part's faster, you should get to the same result as if this other part's faster. But if we program it procedurally, that's often not the case, right? So the takeaway here is, I think we're modeling asynchronous stuff wrong. And this is actually what Eric Niebler is working on now, probably with very different syntax and ideas and whatnot, you know, sort of the more event-based, more more sort of Node.js-y kind of view of the world. Reactive, that's the word I'm looking for. There we go. Because, you know, I work on microcontrollers, and there are people that actually program microcontrollers bare metal in JavaScript. And that sounds incredibly inefficient until you realize they're using a much more powerful paradigm, right? They're using reactive programming. And in reactive programming, once you're done reacting to something, it's obvious you can sleep, right? So these things compared to a scheduler, and in a cherry-picked use case where you don't have a whole lot of stuff to do, where you wake up like 3 times a day and do something, and then you should fall back asleep, but the scheduler has to wake up again and again and again to see if somebody's sleeping and waiting for a timer to tick down or something, right? Something you don't know about. JavaScript wins on power efficiency. And we're obviously doing something completely wrong if JavaScript is winning on power efficiency, right? And it's rooted in the way we sort of express these flow graphs. It shouldn't be like, I'm just going to sleep until something happens, and then in this thread I'm going to do this, and everybody has their own stack, and they're not RAM efficient either, and blah, blah, blah. No, it should just be a graph, right? So I haven't submitted this talk anywhere yet, because I don't know if it's going to work, because I haven't played around with it. But on a conceptual level, I think we should be expressing these things in a more declarative graph manner. Which brings us actually to state machines, which are also a graph, right? So who's familiar with Boost state charts or Boost MSM or Boost SML? A couple of people, yeah, a couple of hands going up. People worried, maybe I know what's going on there. This is essentially a one-line replacement, right? So what are we doing here? We have a pack, which is our state machine. Our state machine is just a variant of all the different states it can be in, right? We're unwrapping it, because obviously we want some type. Don't actually want to pass the variant. We're passing in the event, and we're piping that into this overload set called transition, right? And this is another thing that really bugs me about visit. I can visit with multiple variants, but I can't visit with a variant and a couple of non-variants, right? Like, those parameters just get passed on, right? I mean, I can make a variant containing one parameter, move it in, and yeah, but that's stupid, especially because the Cartesian product of all of those types is still not just one more, because it still has the values by exception, and yeah. But that's off on a tangent, right? We're taking a sum type of all of our states and an event, I'm piping that into transition, right? And it's going to pick one of these overloads of transition, depending on the combination of state that it's in and event you passed in, right? And this is just a function declaration, right? But we're going to return the next state we're going to be in, or nothing if we don't want to transition, right? So coming out of transition is going to be one of any of those things, which means a variant of variance. We're going to join those all together to be one variant, right? We're going to collapse that back down to a variant of S1, S2, or S3, taking out the nothing, right? We're going to do nothing if there's nothing. The result of that collapsibly nothing, so bind won't happen, right? We're going to bind the original state machine, and then we're going to assign, right? Why don't we just assign the result to here to a state machine? Well, because that wouldn't be monadic, right? If we had nothing coming out of the other end, then we'd be binding nothing into the state machine, right? So we're appending it to the end because it's going to short circuit if we return to nothing, meaning we didn't want to transition, right? So this state machine is super intuitive, right? What's an on entry? Well, constructor, duh. I can see it happening, right? What's an onExit? A destructor, duh, right? What's an internal transition? Oh, I just return nothing because I don't want to change my state, right? External transition, okay, what's a guard? Well, it's an if in the body of my function, right? So there isn't the same intellectual overhead. I mean, people don't even actually have to know these words to program a state machine in this manner, right? So this will really help my domain because I have the problem that everything's a state machine and nobody expresses their stuff as state machines, right? Including myself in some cases, because it's just too painful to get everything up and running. I mean, this may be like a one-line replacement for either Boost MSM or Boost SML or whatever. This can potentially be almost as performant, right? But since we did all this in one line, what if we do stuff in more lines? Can we make state machines more awesome? Right? Oops, I'm getting ahead of my highlighting here. Let's build a more powerful state machine. Again, it's got to fit on a slide, so it's kind of ugly, right? So in this case, we have our state machine, which we're unwrapping, right? Is what we're taking as a parameter here. We're forwarding in our event because we weren't doing that properly before, right? Then we're passing in the overload set, right? So you can decide, this is sort of a generic function for users to just say, hey, post event to this thing with this overload set, go for it, right? So for the user, this will be less of a line now. But we're also doing something clever here, right? This T is basically saying, hey, did the state machine overload set return a state which is part of my state machine? If so, return that. If nothing, return nothing. If it's some type that I don't know about, return that from this function rather than assigning it to the state machine, right? So if it's a state that I know about, if it's another state in my machine, then I'm going to switch to that state. But if it's a state outside of my machine, right, then I'm just going to return that from this whole post event function. So that means we can make a hierarchical state machine relatively easily, right? Here we are in our transition function of this, the super machine. We get an event posted to us. We're just going to post this event to our submachine, right? And notice the state, our state S, is actually a variant again, right? So we have a variant of variance representing our hierarchical state machine. This does wonders for state local storage, right? State local storage suddenly is logical, right? Where's my data? Well, duh, it's there. How do I initialize my data? This is something that cost me a week of my life to try and figure out with Boost MSM, right? How do I get arguments into the state machine? Well, I guess you have like some tag that you put in the constructor and then the following arguments passed onto the constructor of your initial state and blah, blah, blah. This is terrible. But here, dude, you're constructing the next state yourself. Just initialize it, right? So yeah, so the state local storage in my domain is the way we represent object lifetimes of objects that don't have stack lifetime, right? Because heaps are actually very inefficient and very non-deterministic. And I say we in my domain has been my dev team because I haven't really met a bunch of other people that do it that way. Most of them just use a bunch of RAM or pray that the stack won't ever get fragmented or, I mean, come to my lightning talk. There's a lot of terrible, terrible code. And my hope is if we give people an easy way to express object lifetimes that aren't stack-based in some other way, then they'll start doing it, right? Because if I'm that camera in the back, then either I'm taking pictures, in which case I need a giant pixel buffer, or raw data, whatever buffer, or I'm connected to a USB port, in which case I don't need that buffer, but I do need a whole USB stack and all this other stuff, right? And those two should share. And they can share through the heap because I allocate and deallocate them, but that's very inefficient, right? Because the heap doesn't know anything about the data types that I'm allocating on it. If I were to make a variant out of those two, then they can share with no overhead, right? And safely. And there is no scenario of fragmentation where suddenly, because you did things in this order, it doesn't fit anymore, right? So, I mean, the digital camera example is pretty simple. If we had a more complex example where we'd have maybe not one state machine, we'd have, I mean, how would you express a state machine with two orthogonal regions? Have a pair of variants and dispatch to both, right? And then join the two, and whichever one's not nothing, that's where we're right? Like it becomes pretty logical how you can actually just build your own state machine handling out of components, right? So, I mean, we'd like to sort of wrap this all up into an encapsulated submachine, right? So rather than having the user have a variant, that variant have some public interface and blah, 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 then let's make that variant private and all the state handlers private. And then in the public interface, if you give me an event, then I will just handle this event using post event, and everything falls in line, right? Everything works. So if I'm doing this, then can I make a template out of that, right? And another problem I have with state machines is they're not composable, right? I have something that's essentially a state machine, a protocol stack, okay, I know how to send this packet. I don't have any knowledge of what to do if I encounter an error. I want to just defer off to somebody else, right? I don't even know what to do when I'm done, right? You give me a packet, I'll send it. If there's an error or I'm done, I'll get back to you, right? And that's kind of what I'd like to write, but using Boost MSM, SML, whatever, this becomes the problem where we have to write a whole lot of glue code to do it. But if we can just template this thing and say, okay, you put in the type to, the type of state that I should construct when there's an error, and the type of state that I should construct when I'm done, then suddenly you have composable state machines, and you can build mix-ins of state machines, right? Everything works. So the idea here is if I have a way of sort of tersely expressing how state machines work, and state machines are a graph, and I have a way of tersely expressing asynchronous channels, which are a slow graph, then the hope is, with tooling support, and this is a JetBrains sponsored conference. Hi, JetBrains, please build this. They know the types coming out of the end of this, right? They have to do that to put in the squiggles if you do something wrong. And they're actually quite good at that. Like, I've broken them, and then like a week later, it works again, right? Make a graph visualizer thing so I can say, hey, I wrote this thing that's actually a graph. Can you like draw it for me so I can see if it's actually a graph that I wanted to draw or I wanted to make, right? I mean, there's a lot of, enterprise architect-y stuff out there where, you draw state machines and you draw flow graphs and you draw all this stuff, and then you push a magic button and code that's obviously been formally reviewed and proven, generates you, that's a joke, by the way, nobody believed that. You have this giant generator monster that's built on top of Eclipse, whatever, or I don't know, and it's, you know, this several million line code base that then spits out your code, and the promise is that you will be able to see the architecture of your program at a much higher level, and you will be able to reason about it. And this promise, if we could have that, that would be amazing. The problem is you're putting all your intellectual property, first of all, in a product that you don't own, and on top of this giant stack of other people's code that's, for the most part, not even maintained anymore, right? If you think about the Eclipse stuff, right? And so if you ever actually want to take that IP and change something and something breaks, have fun, right? Like you sold your soul to a loan shark for tech debt, if you will. I think this should be going the other way around, right? I mean, this is kind of the Microsoft Word versus tech, right? LaTeX. I mean, some people want their what you see is what you get editor. And there again, if something goes wrong, then you start over again, right? Like if you screwed up the index thing, then you, okay, everything into Notepad or something to get all the formatting back out, and I'll start again, right? On the other hand, you have LaTeX where you express yourself in code, and we're good at expressing ourselves in code. So if we express ourselves in code, how the data flow graphs work, how the state machines work, and then have a tool take that and turn it into a picture of, you know, what's going on, then I think we can bring back a lot of those code bases from the, you know, proprietary domain-specific languages, soldier soul world into the ISO world, right? So I got some time for questions. A lot of time for questions. Yes.
Didn't quite get with piping. If you have two variants, how does it pipe them into one function?
Oh, yes. You have a pack of variants.
Okay.
Right? So if I have, let's unpack that, pipe it into foo. There we go, right? So we can visit on multiple of them, right? The other thing that I apparently wrongfully took out, because I blew through this a lot faster than I expected, was the concept of subvariants, right? If I filter on a variant, what am I actually doing, right? I'm not changing the buffer size. I'm just saying, hey, this index and that index, as in this type and that type, can't be in there, right? So we generate a lot of visitor bloat by, you know, for variants where the handler is actually the same thing, right? I mean, if you look at the variant implementations in standard library now, a lot of them are built on like virtual functions and stuff like that. And so obviously that's bound to the type of the variant, even if you just took one case out, right? And you know, usually within the virtual function, whatever it's actually doing is going to get inlined into that virtual function because it can't go the other way, right? Can't like move the virtual function call into that, right? So with the concept of like a filtered variant and, you know, whatever this sum type is that's going through pipes, we can define this however we want, right? We can say, okay, this is a variant, but tick off those two indexes. They can't be in there, right? And this object can be used in the same, like, you know, binary interface as the greater variant, right? So if you have a greater variant, any subvariant of that, as long as the indexes line up, can be used in that can be used with any code that does that, right? And code bloat, again, it's got to fit on like a tiny microcontroller chip in my domain. So code bloat's something that I'm worried about, right? So in my systems, there's one supervariant type that holds all the types that can be dynamically allocated. So anything that's an event, anything that's flowing through queues and whatever, and it usually ends up being a list of like 100 types or something. And then everything else is a subvariant of that supervariant, right? So all of the so if I have a handler for event type X, as long as X is the same index, then I can handle X no matter whether it came from this queue that has this set of events that can go through it, or that queue that has that set of events that can go through it, right? I mean, you know, the problem with variant is its public interface, right? I mean, there's a lot of debate within the standard library, not the standard, the standards committee, about sort of language level variant, and we could have Rust match and all that, same as like our language level tuples, and it would compile faster and whatnot. But I mean, what we have today, because of the way that we standardize the public interface, and the fact that it always has a public interface, constricts us in what we, in compile time and sort of expressibility. Right? So let's build a better variant rather than a language level variant, because I love library space, right? Because I can build my own for microcontrollers and don't have to worry about all the stuff that you guys do on real machines. I mean, you know, who actually uses anything besides visit on a variant, right? I mean, they have like get by type and get by index. I mean, yeah, I use that too, right? Like it's not a shameful thing, but it's brittle, right? I mean, you know, if I say, especially if I think I know what's in the variant and say, okay, well, just, you know, get this and then do something with it. Yeah, that should be a filter and then a visit, and then it's clear what I'm doing and it's safe again, right? I mean, get by index is a bit of a problem because, you know, filter was by type, but what does it mean to pipe a variant into a bind, right? Got your placeholders again, _1, _2, _3. Oh, okay, index-based. We already have something we can compose to make that work. Other questions? Yes?
How do you plan to handle a chain of unwrappings? I mean, let's say you have a tuple inside an optional and you want to like unwrap optional and then unwrap tuple.
Yes, I like the way you think. As far as conceptually, you would just unwrap and then unwrap and then unwrap. As far as syntactically, that really depends on how I end up implementing it in the expression templates, right? Tilde operator, you could do tilde, 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 tilde. I mean, at some point you're going to trigger something, and it's going to be like unmerged commit or something. But, yeah, I mean, you know, conceptually there is room for that, certainly. You know, a variant inside a variant inside a variant, or an optional inside an optional inside an optional. These things actually exist. Yeah. Yeah. Other questions? Thanks. Yes.
Since you mentioned variant inside the variant is painful because you have duplicated indexes and whatnot.
Yeah.
Do you think you can do it like that to pack them all variant inside a variant into one inside the metaprogramming without me looking at?
Yes. Well, I'd have to make my own. You mean basically collapse them together into? Yeah. I mean, you know, the hierarchical state machine example is basically that, right? I mean, I have one variant, which is my super machine, and then within some of those states, I have subvariants and whatever. But I'm really only in one leaf state at a time, if you will, as long as I don't have orthogonal regions, right? But if I have a super machine and then it has in one state some submachine, and then within that one state of that it has another submachine, I should be able to collapse those to where they all share indexes. And If this is standard variant, I certainly can't do that, right? But if this is my variant, sure, I got a template monster, and it does what I tell it to do most of the time. Yeah, I mean, that is potential efficiency gain, right? Because then you don't have the index for each of them. The other thing that you can do, which I love in my domain, if you make your own variant, then you can basically say, hey, do I have more than 256 indexes? No. Index is just 1 byte. Right? I mean, we don't really have sort of policies for that in standard variant. It's always, full word. Yeah, also the valueless by exception. Do people have opinions on valueless by exception? I mean, or I guess probably backing up, what valueless by exception actually is when copying something into this thing or emplacing something into this variant, there was an exception thrown in either the copy constructor or the constructor. And so there's nothing in here. There was an exception, which was essentially swallowed, right? So we already ignored the exception once, essentially, if it's valueless by exception. And the semantics are, if you touch something, then you get an exception thrown at that point, right? Where I don't really understand how that helps, because you already ignored it. Well, yes?
I thought you still get exception propagated on the constructor, and then it's just they have to put variant into something that they can destroy it, right? I think
Yeah.
you get exception in the moment you call it.
Yes, yes.
You don't swallow the exception.
Yeah, no, you don't swallow it per se, but if the thing still exists and you can still touch it, right? Touching it again means you essentially ignored that exception, right?
Don't do that.
Yeah, don't do that. I mean, I'd rather it just be empty. I mean, one of the things that I didn't mention, if your variant has an explicit empty state, I mean, what is an optional but a variant of empty or that thing, right? So we can essentially express optionals and make optionals go through pipes without any extra machinery, right? Yeah, other questions? Yes. Yay, I was expecting discussion and I got discussion.
So I really like the way this is going, and I'm actually quite pleasantly surprised by the syntax that you were able to come up at the end. Like, this kind of chaining of operations is much cleaner than anything I've seen before.
Yes, I'm partly cheating because I'm assuming on some of the slides that some proposals will go well.
So I'm actually wondering, something I'm concerned about is that we have this kind of pipe tilde operator that you came up with
Yeah.
DSLs. We have the coroutines operator, and we might be getting special syntax for static exceptions as well. What's your long-term vision?
Static exception, also a variant, or at least a sum type. Yes.
Do you have any kind of long-term vision of how we might be able to unify these kind of syntaxes rather than having every of these domains and applications have separate syntaxes?
I do have a long-term vision. It's probably crap, which is why I'm doing this talk, right? I think we should have a long-term vision, right? That was kind of the motivating factor to, I mean, actually, in sort of my masochistic way, I overcommit to things. I signed up to just do the same talk here that I did at Meeting C++, which was kind of about, hey, this is a faster HANA, right? But I feel strongly we should have a vision, right? I mean, we have monadic async.then that didn't quite turn out to be monadic because people pulled the ripcord because they realized, hey, this is part of something bigger, but we didn't make it part of something bigger and blah, blah, right? We have the optional proposal, not yet in the standard, might get into 20. That ship might sail, right? The monadic optional. Then we have around coroutines, some other, I mean, people are, the idea of putting part of Haskell into C++ is very contentious. But I would argue that I mean, I don't want to say this because I don't want to jeopardize ranges, but we kind of did, right? Like, ranges will put the list monad into C++, and I can make a monadic optional extension using ranges, because I basically make a range adopter for an optional that is either a range of one thing or a range of nothing, and then I can start piping it, right? So I can hack other parts of Haskell in anyway, right? So, by the way, I don't program Haskell. People just keep telling me that I reinvented something in Haskell, and so I know some Haskell because I reinvented part. Anyway, but the point is we shouldn't have 5 Haskells in C++, right? I mean, that's what we really need to stop from happening, because that's what we're doing right now, right? We're taking like this little bit, right, and we're getting fat and weak, in the words of Bacchus, right? Yeah, so I mean, we should think about extending the ranges DSL to be sort of the grand vision of how we do declarative functional style programming in declarative or functional style programming in C++. Because I mean, this is, you know, going back to sort of the Bjarne style argument, right? I mean, C++ has always been a language that took paradigms from other languages, and I mean, I can't write my programs in Haskell because Haskell is not dirty enough, and my programs have to be dirty, right? I mean, I have things like the time domain and the space domain and like physical addresses where bits need to get to within 5 instruction cycles, damn von Neumann bag, right? Of bits getting into this other thing, right? And you can't express that in Haskell. It's just not part of the language. And I said that on Twitter, and some Haskell guy said, yeah, use this, you can. And I looked at what this was, and it was a Haskell code generator that generated C code and compiled it. And it's actually a really cool thing, because it not only generates C code and compiles it with differently formally proven C compilers and compares the results and proves that they're equal and blah, blah, blah. But yeah, no, I can't. Like, I have to actually ship stuff, right? So, I mean, C++ is never going to be a pure, clean language. That ship sailed, right? But that doesn't mean we can't build like a pure, clean, generic thing on top of it, right? I mean, most people writing Haskell don't really think about how all the functions just take one parameter. If you have multiple parameters, then it's a curried of a bunch of single parameter functions and all that crap, right? You don't think about it. I mean, you fold and you use very high level stuff that builds on all this low level stuff. But if we were to swap out all the low level stuff and just say, okay, here's the high level algorithms from Haskell, they work much the same way, then the low level stuff can be all this dirty stuff that we need, right? So yeah, I mean, we should build our own little clean language within C++ to embrace some of these paradigms that C++ doesn't really support very well.
Do we even have any chance of standardizing that in the first place?
Oh, I'm not the right one to answer that question. I've been to one standards committee meeting, and I don't quite understand the power dynamics of the, although I think I do sort of a little bit. But anyway, I think, I mean, basically what this is Haskell point free, but going the other way around, right? Because for some reason, Haskell point free binds the other way compared to yay, right? So, but I think it would be probably wrong to make Haskell programmers feel more at home in C++, because that's the uncommon case, right? You want to take C++ programmers and make them feel happy in a cleaner subworld, right? And that's basically what ranges, I mean, that's kind of the essence of ranges, right? Like we have this sort of cleaner subworld, but we express it in terms you might be already familiar with, right? And to make sure that my kids are familiar with this world, I named our vacuuming robot Iota. So they know what IOTA is. It's the vacuuming robot. And later they will learn what IOTA really is. But anyway, so I think we should express the DSL in the terms that are easiest to explain to the current C++ programmer base, right? And not necessarily look to Haskell for syntax. Yes?
So along those lines, so a couple of slides back we had, well, we had a bunch of type predicates, which I was having a huge amount of trouble reading. I don't know if anyone else was.
Oh, yes.
Those, yeah, yeah, that kind of stuff.
Yes, this kind of stuff.
That looks like the words of C++ free mixed with some pretty hairy Haskell as well.
Yes. Okay, what this is, the stuff with the underscores at the end of it, this is the same stuff that we're seeing in a fusion-based world where we have type information and value information that's coming in at runtime. This is that same thing, but in a world where we just have type information, right? So this is the boost MPL equivalent, right? Or the boost MP11 equivalent, or this is not sort of the boost HANA equivalent, if you will, right? So this is ugly. I can make it prettier, but it'll be less fast, right? And the amount of template magic that you can have depends on how fast your template magic compiles. And so this is the prettiest that I can make it with it not being slower, right? Yes, slow to compile. Sorry, I need to, yeah. I mean, for reference, this is, again, a DSL on top of template metaprogramming, and it is more readable than, in my opinion at least, and I have taught this to students and feel pretty confident that it's more teachable than the raw template metaprogram, if you will, with all the template disambiguators and all that stuff and all the tricks. I have, in previous versions of this talk and other metaprogramming talks, I've shown benchmark comparisons of stuff written in this DSL, compile time benchmarked, as in how fast does it compile, against implementations in libc++ and libstandard C++. And this is faster than the voodoo that they do in the most cases, right? So it is more readable than that, right? We will be getting new metaprogramming, hopefully, out of the reflection working group, SG7. And it will be much more readable and much faster. So this is probably going away again, but for the people that need to do this now, and the other advantage of wrapping the actual template metaprogramming in a domain-specific language is you can't see the implementation. I can swap it out for different compilers again, right? I can take, these compositions, those types will be created, right? But the types passed in, they don't need to actually create new template instantiations, and they don't a lot of the time. Sometimes they do because there's no other way to express it in current metaprogramming. But if we get better metaprogramming, I can take those instantiations away, and making new types is the slow part of template metaprogramming, right? Like passing parameters around and doing things, big O notation is not what you look for. You look for a number of types, right? And so I can swap out the back end of the DSL and make the type-based TMP stuff that you write today in C++ 14 for the sake of argument, or whatever you can use at work, and make it run faster when you upgrade, right? So yeah, this is ugly, and I did put it in because if you want things to go super fast and you just are worried about, and in this context, you're just interested in type, right? In this context, we're matching on type and not value, obviously, right?
Well, so the other thing would be that, just think about it now, so in
I haven't played around with concepts much yet. I did at some point, and at that point, the implementation of concepts was actually slower than what I was doing.
I'm not talking about speed, I'm talking about readability.
Yeah. I'm not quite even sure how I would capture the concept, and I probably could. Yeah. I mean, if not, somebody should write a proposal so that you can. But, you know, Rust match-ish thing on concept constraints, that sounds like a good idea. Was that a question? Oh, yeah, okay, yes.
On the last slides, you had some weird operators. Can you show them again?
The last slide, some weird operators.
Later. Inside the struct, there's template conversions with parameters or whatnot. Yeah, well, this thing, auto operator, this is conversion to...
Oh, yes, well, oh, you're right, I'm missing 2 round brackets.
Oh, okay.
And apparently, I should have gotten red squiggles and I didn't. Oh well, yes.
It's a converter.
Yes, that's why I didn't get red squiggles. No, this should be a function call operator.
Oh, okay.
Sorry. Yeah, I think I'm done-ish. Yes. One more question? Oh, 5 minutes left. 2 more questions. Yes, in the back.
So, you mentioned that, for example, Eric Mead was thinking about this sort of thing.
Yeah.
He's talked about how generalizing the stuff that he's done in ranges and how that relates to coroutines and how that
Yeah.
relates to heterogeneous computing. So, are you planning to discuss this stuff? If we want to have an overarching scheme for this sort of thinking in C++, are you planning to discuss this with Eric?
Yes, I have been, to some extent. I'm very time constrained because I do a bazillion other things, and I have kids, which eats the vast majority of my time. But, and this is mostly free time, which mostly doesn't exist, so that's kind of, yeah, anyway. But yes, I have talked with Eric a bit. He gave sort of his preliminary tentative thumbs up to the whole idea of extending his DSL to encompass a bunch of other stuff. I mean, he's certainly doing it in the reactive space. I should read into that before I give any sort of opinions on that. Like, I don't really know what back pressure is. I'm not sure if anyone else here wants to explain to me what back pressure is in a reactive context, but I mean, in my world, the reactive, the async data flow graphiness, and the reason why I've been thinking about this a lot is DMAs are very underused on system on a chip or microcontrollers. And one of the reasons is it's very hard to think about them, reason about them, extract them. Like, what is a DMA transfer in C++ semantics, right? If I have thing A and thing B, how do I express the relationship such that something is asynchronously transferred between the two of them, right? I can express that as a graph if the connections in my graph are also my own types, right? If I can say, I want to connect that node to that node with this connection policy, if you will, then I can express a lot of DMA stuff. And this is very sort of preliminary that I'm playing around with right now. But I mean, you know, concrete use case, I have a USB stack, and I have an analog digital converter. And I want my analog digital converter data to drop into USB packets in the region of RAM that the USB DMA can find, and chunked correctly such that I don't have to copy this data around, right? But I don't want the two to know anything about each other, right? And I want to go from DMA to that, from analog digital converter to that RAM also with a DMA, right? So obviously I'm not going to have a hardware DMA that understands my packet structure, right? Maybe the first packet in the bunch will have a longer header, so I'm going to put less stuff in there and blah, blah, blah. But since I modeled the whole rest of my system to be lock-free, as in I never turn off interrupts, which is why I can't have a heap, because that would be a shared resource, so you'd have to turn, right? Because of all this, I have super, super low interrupt latency, so I can actually set a timer, because the ADC is a hard real-time thing, so I can count how many cycles in the future I need to re-aim the DMA, set a timer to re-aim the DMA between ADC conversions. So I can do this if I write it in assembler, but I'd like to write it in C++, right? So how does the USB communicate what its memory layout is, the protocol get in between there, and the DMA know that it has an interrupt and it can react to that? But I can't make that work any way in generic code unless it's a composition of nodes and connections in a graph. And then I can make it work, right? And so my gut feeling is that this will allow a lot more. I mean, I did some programming using I/O completion ports on Windows, right? Which is basically a lock-free queue. What I came up with was something like boost.tmp. I was too stupid to find boost.tmp, so I built it myself, which story of my life. I don't know. I'm sorry, but I can't make that work in like futures, because futures allocate unconditionally. And I can't have an allocator if I need one thread to never lock, right? Because there's a lock around the heap, damn it. But I can make that work with this, right? I mean, an overlapped I/O structure, well, that's just an optional, right? It's a fancy optional, but to go through pipes, you need to just fulfill some interface, right? And then, yeah, I could have made that work in this sort of async graphy thing. So, yeah, I guess that's my whole talk. Thank you all.